So this is what we're going to call problem 13.0. This is working the problem within the chapter involving sheet metal. So let's get started. I think this might be a sheet metal part in inches. So let's just go double check on that. If you look at the diagram right here, looks like all of those are going to be in inches. So we will go ahead and create that one. And we'll go up here and set all of the sheet metal settings before we get started, such as the K factor, which they described there, and also some of these other things. So we did this, and we're going to go down here to sheet metal defaults. And I guess we're going to set the default sheet size. Let's get over here a bit so we can see this. All right. So we're going to select this default, and we're going to change that over to, let's see what they're going to be doing here. Generic. Okay, it says default read only. Okay, so let's see if they're going to have us change any of that. Okay, they want us to make a new material. And so this one's going to be called 16 gauge. I think we determined this is a 16th of an inch mild steel. Okay, and so this is our new material. And so down here, steel mild ought to do it. And as you may remember, a 16th is 0.0625. All right, got that in place. K factor time. Um, okay, it wants to save these edits we just made. And are we going to make a new K factor as well? All right, I guess so. So new. Um, we're going to call this V bend and 16 gauge mild steel. You'll see that the value is going to be different. So it's going to be zero point 0.1 instead. I'm sorry, 0.41. 0.41 right there. And instead of linear, we're going to do a bend table instead. Okay. Now, on this other one, I want to make sure that's right. Yeah. Bend table. All right. So we have, doesn't look like they're creating a bend table at all here. Okay, so I misread this. It says note that for complex settings we'll be using a bend table. That's not that they're doing that right here. So we want to make sure we save and close to get that in there. Now the thickness, surprise, it's using this one. I guess we need to make sure we select that right there, save and close, so that it uses, oh, okay, I guess we got to select it there. And do this one more time and check on this K factor to make sure that we selected this one. Okay, that's interesting. Okay, so we'll make sure we did it one more time here. There is already selected. And then on the K factor, we created a new one and we need to select it. Uh, I guess make it active. I guess that's right. Then make this one active. Doesn't really say to do that, but it feels better when these kind of look right. And the material we said is mild steel. And this one right here is the unfold roll. Good. Then what is this last one here? Okay, edit the style sheet. Edit sheet metal rule icon. So sheet metal rule, sheet metal rule. Okay, I think we already did all of this though. We need to look at the bend, making sure it says thickness 0.5, 2, okay, thickness, and then down here for the bend relief. Okay, bend relief shape. I'm going to say it needs to be round instead. And then they do the thickness down here times 1.5. I think we have all that in place now, so go like that. And I guess we can close this out since we saved it. And then finally, we're making our part. That's a lot of effort for that one. And so I guess we can do this on any plane, but it says use this one. And so we'll make the base shape. Center rectangle seems like the best thing to do, like this. And we'll make that top one 1.508. If I can see that properly. Yeah, 1.508. And then the other one is 1.62. Then we're going to make all these little notches in place, like right here. Looks like maybe a 2-point rectangle would work right there. All right. And then we do things like make each one of these equal. So this one and that one and this one and that one. We're also going to make these right here equal to each other. Right there equal to each other. And then across the pond, make this equal to each other as well. Lots of symmetry going on there. Let's see if we can lock down this and make it fully defined, fully constrained. 3, 2, 5. And then the distance between here, I guess we can select the corners, not so bad. 1 inch. A little bit different than the way I did it in class. Um, it works. 0.745. Hopefully we're still fully constrained down there. There's a couple of ways to make these. I'm going to try using, like we did in class, the slot feature. All right, dare we just do all four? It's not how I did it in class. I used symmetry and repeatability, but it's okay. All right, so the first thing we want to do here is add some symmetry. I wonder if we can, well, we will just say the distance between here and the origin is going to be 0.33. Now, what they did was they made it a function so that it depends on this other one, I'm sure. But we will just continue on. Since we're not going to modify this sheet metal part after we get it designed. Then the distance from there to there is a quarter. Well, let's start making things equal to each other after we get this 1/8 in place. 0.125 for 1/8. Now let's see if we could make a bunch of these things like equal to each other. Like, can we make that radius equal to this one? And can we make this radius, that one, this radius, this one? Sure. And then other things like, can we make this distance equal to that one? This distance equal to this one, and that distance equal to this one. So you see there's no dimensions over there for those. So they're wanting us to use those kinds of relationships. A collinear between this one and this one will help. And this one will help also. And we're fully constrained. So let's just try to say, hmm, should we split like this? And then make it hidden? Because we don't really want it to be part of the part. We could just say, can we delete it? Oh boy, did it? Okay, see, that's the problem is it makes it, if you remove it, it makes it lose its constraints. So that's usually why I like to, I guess, let's see if we can just select it. Can I select? No. How about shift click and then go like this? There we go. See, we don't really want it to be part of the extrusion. The thing is, I don't think even really matters because at the end of the day, what you're going to do is select this inner part right here. So let's see if we can just leave it alone and then go ahead and do our sheet after we finish our sketch here. Because you can see they actually left this part out over here, which is going to be a vacancy, as we're about to find out. So we're going to do over here on this sheet metal, we're going to make a face, and look at that. We're selecting this, and it didn't even matter what that those curves existed. By leaving them there, though, we are allowed to keep it fully constrained. Make sure that we select the 16 gauge because we made that the default. And uh, what is it doing here about the unfold options? Shape, unfold rule. So these instructions look a little bit different than the previous version over here. So we will continue hoping that I got that correct. This is looking good so far. Um, looks about the same. We will find out as we move forward. We start measuring things. So I guess they're asking us to measure the thickness of this to make sure it came across properly. So we do an inspect measure, and we just look at that little edge right there. And not surprisingly, it's that right there. Now, I wonder what, oh, no, I thought that was something I needed to do. I wanted to show more digits there. Okay, so hopefully we don't have to worry about that part, about it having more digits. But if we wanted to do that, you know what to do, right? Document settings, units, and now we go crazy with this overkill here. Then close, inspect, measure, and fantastic things, except for this not showing it right. Oh yeah, it doesn't even show it there either. Did I not do something right? Let's go back up here, done. Tools, document settings, units. Yeah, I even set it there and it still didn't show it. But that's just, I think, the way the measuring tool works as opposed to how dimensions work. All right, so we'll close that down. Now we're going to put a flange in there. And I guess they want everything to be, let's see, 90 degrees. All right, so put the flange on there. And I want to know where it goes because I kind of want to see it, as it's happening here. So they're going to rotate it around this way. Not like it really matters, but just to get a look at it. Um, to get a preview of it, I think it's going to be like that, but no, that's not it. So what you can do is if you get that incorrect here, yeah, you just hit cancel. And we want to select this edge here so that it curves this direction. I'm going to hover above it a little bit so you can see that little curvature right here as they have here. Let's go back up and make sure we get all these settings proper now. All right, so looks like these are all just default settings right here. Okay, bend position. All right, let's just start with the height extents first of all. Height extents needs to be half of that. So it says select outside of base facets. So bend position. All right, this is, I think it's this position. Oh, yes, position. And it says outside of base face extents. So they kind of changed their wording on this a little bit, looks like. Plus the height datum. So let's see which one of these really applies to us. So you can see this is a previous version of Autodesk Inventor. If you look at that little line, it's going on the inside of that. That's what they're asking us to do. And so it's this one right here, measuring that distance. Okay. And it says to go over to the bend, but I think we already have all of this. The bend property is all defaults set to really what we want it to be. We've already selected the edge, and then we say OK. So there's that. And of course, we want to do the other one and then make sure that minimum distance is the 1.508. So perhaps if we edit this flange here and then also click right there, we can get two for the price of one. Then face it, face the front and measure. So not by adding dimensions, but just by using the measure tool. Let's make sure this inner one is what we want it to be. Right there to there, 5.08. Perfect. So we did it right. It's a good way to verify it. And you'll also see that this little groove right here is the what is that, 16th of an inch, I believe. And so now we're going to start drawing on this outside surface right here. Right click, new sketch, right click. Oh, wait. It did not let me do that. New sketch. There it is. All right. And we're going to add on these features. So we're going to be doing, making these slots up here and all these extra lines. So let's get started. First of all, go off in this direction here, then go up. Now here we could go over just to represent going across here, and we'll put those arcs up there just a bit. So again, going like this, then back down until, it doesn't look quite like it went through there. So I guess I will assume that it doesn't do that. Um, and then if I have to make the assumptions at the end, I will certainly do that. Okay. So I'm only going to draw that half and then make a mirror image of the other half. So using the slot tool, we can go here and make that one right there. Putting those dimensions in place. We can delete this one right there and just put an arc in there that starts at this center and goes from there to there. Let's get some actual numbers in here though. Um, Looks like it's going to be a quarter right here, which doesn't seem right. It says 1.25. There's no way I'm off that far, is it? 0.25. Guess it's just bigger than I realized. Maybe. We got 150 degrees right there. We got pretty close. Now the distance from this line here to where that one is, as we can see, is the 0.4. Turn that into a bulb up there. We know how to fix that one, right? Just use our tangent tool, straighten that business out. Okay, and then the distance right there is 1/8 of an inch. 125. And this one, I'm going to say is 0.06, 0.0625. I'm assuming that that got rounded off because that would be the 16th of an inch that we're looking for normally. Okay, so why is it not fully defined? Well, let's go from this area right here. That needs to be a half. And the distance from there to there, I guess I could have said midpoint, but they're just going to say use the dimension tool to do it instead. So they're saying it's midway, just in another approach. All right, let's keep going here. Got this distance point. Um, okay, where's my dimension tool at here? Sketch. And right here. We need to be from that surface all the way up to this area is going to be 0.615. Okay, let's see what else we have here. I guess it's understood that these two lines are parallel, so let's make those parallel. This one and that one. Kind of imply that that's the case. And then we have another dimension from this outside to the outside. 0.820. Now I'm trying to figure out why this would be undefined here since we did this one. So is it the fact that it's not vertical? So we'll get confused about that. We just do this right here, and it looks like it could actually rotate, which I don't know how it thought that that was the case. But when that happens, we look along the y-axis and say that's vertical, and then try to make, this vertical as well. And it did that. Fully constrained now, let's make a reflection of our sketch so we don't have to do it twice. Where is the reflection section? Here it is. Looking for a pattern. So it says select things, And I'm going to try to have it select that. We don't need to reflect that one. And then it says the mirror line, and I don't really have one drawn. So can I use the x-axis? I don't think so. Can I use that dot? No. So when those kind of things happen, you know what to do. Just make you a reference line. Start here. There's my dog again. Go out to there. Let's make sure that is, I think it's just covered up by this construct dimension. You can see that it is hidden line now. Mirror image of what we select, and then the mirror line is here. Then you apply, and there's our other part down there, still fully constrained. Done. Beautiful thing. Now, is it time to make a face from that? Sure. So let's go face it, face our demons there, and make sure that it put it on the right side. And it did. And I guess it's going to say mirror it just like we did the other one. So you select the part you want to mirror, that face right there, go to 3D model, you find the mirror, and hopefully we put it in such a way that there's a plane in between the two. I sure hope we did. So you just kind of look for which plane is bisecting everything, and it looks to be that one. And you're done with that. Not so bad, right? Looking pretty good. So we did all that. Phase two, we use the origin. Well, they said to do it that way. And so then we're going to make a slot here on this flange that we put out here. So right click, new sketch, and let's put a slot out here. And why not, since we're along the z-axis, I don't know if it's going to let us do this. Sometimes it's hard to know if horizontal or vertical or what we need to use to line those up. And that clearly was not it. So I think it's going to be this one, even though, yeah. So we wanted those to be lined up horizontally, but it says z-axis. So sometimes you just can't tell which one is which. We want the dimension between this back panel and the focus point of that um, slot to be 0.3. We want this radius to be 0.0625. Oh, wait, it just says 5 now. Okay, we'll leave it like that. And it went way too big, so I typed in something really wrong, I'm sure. Can't wait to look back at the video and see what I typed. Zero. Oh, I bet I know. It's just, okay. All right. And then from there to there, we need a dimension, 0.45. And I've already lined these up, but they just made this one half of the other one. We have it fully constrained. And so we can now do a cut. And we're going to do a cut not on the 3D model tool, but on this tool here on this sheet metal tool. So it does a proper kind of cut. Are we going to do another oh, it put the thing out there. Wow. It drew the thing here and it set it on both sides. I drew it on this surface. I wonder if I can just do this and achieve the same principle. Yeah, they did a mid-plane expansion. I did not do that. Okay, so now it's time to draw a line here to make a bend, and we're going to orbit around until it looks like theirs. Let's just keep clicking these until it looks like theirs. Click these corners, and there we go. And so it says select this face right here, make a new sketch. Let's put a line up there. And it says to, well, try it again. Much better. Put a line um, in just a weird place. And hopefully it didn't think I was trying to do the midpoint. Although it seems to kind of have it fully constrained. So it must have thought I clicked on the midpoint there accidentally. So I'm going to hit Control Z to make sure I don't put it on the midpoint because it's probably going to have a different position. From here to this origin needs to be 0.535. And we're going to finish the sketch and fold. So sheet metal, um, and where is the fold tool? It's right there. Okay, and then we need to select the bend line, which is right there. Let's make sure we got all the settings in place. It wants us to use this one right here. The fold location needs to be um, this one. Okay, so that kind of defines how they're wanting us to bend this. That's a little bit different than the way I did it in class. It says, oh, we want the control direction to go this way. Oh, I don't know about that. It just doesn't look like it's going to bend it properly to me. Because if you look here, it does not look like it's supposed to right there. That's just not right. So let's reread some of their instructions. Okay. It says flip controls. So the fold location is right here. Okay, that's the direction of the bend. I just don't like that fold. Just not look right. We don't want to get rid of that line though. But we will come in here and try that fold again. And just click OK. And let's see if it looks closer to what they have. So they might have just been telling us there's these other things that you can do. Okay. Bend line. Mirror. Okay. The question is, does this look like this? And it does. So I'm not sure why they would want us to use this flip controls or even this one as well, because that's not what we end up using. We can investigate those features by saying, what does this one look like? Okay, that was all right. See if it looks, yeah, that looks okay. Let's see if it's different than what we had before. So this one right here. Oh yeah, okay, so that is different. You can see the way that it's doing it there. I think the only thing I disagree with is using that one right there. Um, it wants to do a mirror on this. I don't think so. Although it does, looks like it's right here. Okay, so we're actually mirroring the fold. So you click this one, and then you go up here and find where the mirror is. And then you got to select some kind of mirror plane that goes through the middle. And so it performs the same action on the other part. Beautiful. I didn't even save it the whole time. Remember to save this one as problem 13.0, doing some sheet metal, and save. Home position. And let's just see if we can create a flat pattern. Sometimes it works, sometimes it doesn't. Look at that. Folds it out so you can stamp this as a metal and as one sheet of metal. And then you have another machine that performs the bends. You can do all these measurements for testing purposes. double check them out. So kind of quality control is what is telling you what you can do as far as quality control. Okay, so let's see, what is the rest of this here? Okay, so then we can go ahead and do the sketch if we want to, but all I really wanted to do on this one, I believe, according to D2L, is going to be just the part. Let's double check to make sure that's the requirements for this assignment. Right here, and it says just upload the IPT file. So you do not need to go further with that and make the PDF file. That's all you needed there. Hope this video helped you get through the process. And let's see, can we go back to the folded part and save and make sure we upload that? All right, thanks for watching. I'll see you in the next video. Have a good one.